everyone. In this lesson, I will complete solving the ministerial question of lesson 3-4. We reach question number 20. A point moves on x-axis according to the position function s of t equal to t squared minus 5t plus 4. At what time the point moves to the left? The point moves to the left when the speed function is less than 0 under x-axis. First, we find the velocity function equal to the derivative of the position function 2t minus 5. Set it less than 0 because we want to find at what time the point moves to the left. Then 2t less than 5, then t less than 5 over 2 less than 2.5. 3 is greater than 2.5. 2 is less than 2.5. 5 is greater than 2.5. And 5 over 2 is equal to 2.5. Therefore, the right choice is B. Question number 21. At a point moves on x-axis according to the position function s of t equal t squared minus 6t plus 7. At what time will the point moves to the left? It is the same steps of the previous function of the previous question. Find the velocity function, derive the position function 2t minus 6, set it less than 0 because we want to find at what time the point moves to the left, then 2t less than 6, then t less than 6 over 2 less than 3. Here it's wrong, here it's wrong, wrong. The right choice is a half because a half is less than 3. Question number 22. An object moves according to the position function s of t equals sine t plus cosine t. At what time moves to the left? The point moves to the left. Also, we find the velocity function, find the derivative of this function. Sine t, its derivative is cosine t minus sine t, the derivative of cosine t. To the left, set it less than 0. Then cosine t less than sine t. We want to find at which point cosine t will be less than sine t. This is the graph of sine. This is 2 pi. This is pi. This is pi over 2. And this is pi over 4. This here 3 pi over 2. And the graph of cosine is like this. At 0, cosine is greater than sine. The value of cosine is greater than sine. So this choice is wrong. At pi over 4, the value of sine is equal to value of cosine. At pi, the value of sine is greater than the value of cosine. So this is the right choice, C. Question number 23. An object moves according to the position function 3 plus sine t. S of t equals 3 plus sine t. At what time will the point stop? Find first the velocity function. Derivative of 3 plus sine t is 0 plus cosine t. Set it 0 because you want to find at what time the object stop. Then t equal to cosine inverse 0 to find this from the graph. This is the graph of cosine. Here pi over 2 and here 3 pi over 2. So the right choice is pi over 2. Question number 24. A point moves on x-axis. The position function of it is s of t equal t square minus 6t plus 1. T in second, s in meter. Find the average velocity during this period t equal 4 and t2 equal 7. The average velocity equal to s of t2 minus s of t1 over t2 minus t1 equal to s of t2 at s of 7 minus s of t1 s of 4. S of 7, it is 7 square minus 6 times 7 plus 1 minus s of 4, 4 square minus 6 times 4 plus 1 over 7 minus 4 equal to 7 square 49, 6 times 7 42 plus 1 minus 16 plus 24 minus 1 over 3 equal to 49 minus 42, 7, 1 with 1, a negative 16 plus 24, 8 over 3 equal 15 over 3 equal 5. Choice A. Question number 25. The position function of a moving object is s of t equal t cube minus 6t square plus 9t meter per second, plus 9t in meters. Find the velocity of this object where the acceleration is 6 meter per second square. First, we find the velocity function, v of t. Find the derivative of the position function, 3t square minus 12t plus 9. Then, we find the acceleration function by derive the velocity function, 6t minus 12. Then, we find the time when the acceleration is 6. Therefore, set acceleration 6 and find the time where the acceleration is 6. 6 equal to, factorize by 6. Therefore, t minus 2 equal 1, t equal 3. Then the acceleration of this object is 6 when the time is 3. Substitute t equal 3 in the velocity function to find the velocity function at this time. 3 times 3 square minus 12 times 3 plus 9 equal to 3 times 9, 27, minus 12 times 3, 36, plus 9 equal to 27 minus 36 minus 9 plus 9, 0. Choice A. Question number 26. A point moves on x-axis with a position function s of t equal t square minus 5t plus 10. T in seconds and s in meter. Find the instantaneous velocity at t equal 4. Find the velocity function first. derivative of the position function 2t minus 5. The instantaneous velocity at t equal 4, substitute t with 4, then 2 times 4 minus 5, 8 minus 5 equal 3. Choice A. Question number 27. A point moves on x-axis according to the position function t squared minus 6x plus 5. T in seconds and s in meter. Find the average velocity during the first 4 seconds. The first 4 seconds means t1 equals 0 and t2 equal 4. The average velocity equal to s of 4 minus s of 0 over 4 minus 0 equal to s of 4, substitute 4 in the position function, 4 squared minus 6 times 4 plus 5 minus s of 0, 0 minus 0 plus 5 minus 5 over 4, negative 5 with positive 5, then 16, 4 squared minus 6 times 4, 20 equal to negative 8 over 4 equal to negative 2. Choice C. Question number 28. A point moves on x-axis. The position function of this point is s of t equal t squared minus 6t plus 5. At what time will the point moves to the right? Moves to the right means the velocity is greater than 0 over x-axis. First, find the velocity function. 2t derivative of the position function minus 6. Set it greater than 0. Then 2t greater than 6. Then t greater than 3. 0 is less than 3. 5 is greater than 3. T is equal. 2 is less. The right choice is B. Question number 29. The function of velocity of a moving body is v of t equals 36 minus t squared meter per second. Find the acceleration of this body at t equals 3. The acceleration is the derivative, the acceleration function a of t is the derivative of the velocity function negative 2t. At t equals 3, substitute every t with 3, negative 2 times 3 equal to negative 6. Choice A. Question number 30. A point moves on x-axis. The function s of t equals t cubed plus 6t squared plus 9 is the position function of this point. T in seconds and s in meter. Find the average velocity during the first 2 seconds. The first 2 seconds means t1 equals 0 and t2 equal 2. The average velocity function is, rule is s of t2 2 minus s of t1 0 over 2 minus 0 t2 minus t1 equal to, substitute 2 in the position function, 2 cubed plus 6 times 2 squared plus 9 minus s of 0, substitute 0 in position function is 9 over 2, negative 9 with positive 9, 2 power 3 8 plus 2 power 2 4 times 6 24 over 2. 32 over 2 equal to 16. Choice B. Question number 31. A rocket thrown vertically upward. The function s of t equal to negative 4.9 t squared plus 160 t plus 10 is the position function at time. T is in second, s in meters. What is the acceleration of the rocket? The acceleration is the second derivative of the position function. The first derivative is negative 9.8 t plus 160. the second derivative acceleration of t equal to the second derivative of t equal to negative 9.8. Choice C. Question number 32. A rocket thrown vertically upward with, according to the position function, 32t minus 0.8 t squared, t in second and s in meters. How long does it take the rock to reach the highest point? We want to find the time when the rock reached the highest point. First, we find the velocity function, v of t equal to derivative of the position function 32 minus 0.8 times 2t equal to 32 minus 1.6 t. Set it 0 to find the time when the rocket stopped. Then it is the highest point. 32 equal to 1.60, t equal to 32 over 1.6 equal to 320 over 16 equal to 20. Choice B. 33 is depending on 32, the same given information. How high does the rock go to find? How high does the rock go? Find the position function at when t equal 20. So s of 20 equal to 32 times 20 minus 0.8 times 20 squared equal to 640 minus 0.8 times 400 equal to 640 minus 320 equal to 320. Choice C. Question number 34. A rocket launched upward. S of t equal negative 16t squared plus 128t plus 4 is the position function t in second and s in meter. What is the highest point the rock can reach? The highest point is when the velocity is 0. First, find the velocity function, negative 32t plus 128. Set it 0 to find the time when the rock reached the highest point. Then 32t equal to 128. t equal to 128 over 32 equal to 4. Then find the position function at 4. Negative 16 times 4 square plus 128 times 4 plus 4 equal to 260. Choice A. Question number 35. A ball is thrown vertically upward from the ground level with an initial velocity of 160 feet per second. What is the highest point the ball can reach? The position function of the vertical motion in when velocity is in feet is s of t equal negative 16 t squared plus v naught t plus S naught, where V naught is the initial velocity and S naught is the initial position. The highest point, if we want to find the highest point, we find the velocity function first, then set it 0 to find the time when the velocity function is 0, then substitute this time in position function to find the highest point. The velocity function is the derivative of the position function, negative 32t plus v naught. The initial velocity is 160, then the velocity function is negative 32t plus 160. Set it equal 0 and find the time. 32t equal to 160, then t equal to 160 over 32 by 60 to 10 equal 5. Then find the position function at 5. S of 5 equal to negative 16 times 5 square plus V naught 160 times 5 plus 0, since thrown from the ground level. Therefore, the initial position is 0, equal to negative 16 times 25 plus 160 times 5 equal to 400. Choice B. Question number 36. The position function of the projectile thrown vertically is s of t equal negative 16t squared plus 160t plus 4. What is the velocity of the project when it reaches 260? Then find the velocity function by derive the position function, negative 32t plus 160. Find the time when the rocket reached 260 feet by substitute 260 in the position function. 260 equal to negative 16t squared plus 160t plus 4. Then 16t squared minus 160t plus 260 minus 4 equals 0. 16t squared minus 160t plus 256 equal, divide this equation by 16, then t squared minus 10t plus 16 equal 0. Then use experiment t negative 2 negative 8 equals 0, either t equal 2 or t equal 8. Find v of 2 equal to negative 32t. 32 times 2 plus 160 equal to negative 64 plus 160 equal to 96 feet per second. When t equal 8, then negative 32 times 8 plus 160 equal to negative negative 256 plus 160 equals negative 96. Then the projectile reaches 260 feet twice, moves upward after 2 seconds, and the second time when he moves downward at t equal 8. Therefore, the right choice is 96. Question number 37. The position function of the projectile thrown vertically is s of t equal negative 2t square plus 22a. What is the highest point the projectile can reach? The highest point is when the velocity is 0. The velocity function equal to negative 40 plus 28. Set it 0 to find the time when the rock stop. For t equal to 28, then t equal to 28 over 4 equal to 2147. Then find s of 7, the position function at after 7 seconds, negative 2 times 7 square plus 28 times 7 equal to 98. Choice C. Question number 38. A rock thrown vertically from a surface of Earth with initial velocity 80 feet per second. What is the highest point the rock can reach? The position function of the vertical motion when velocity is in feet is s of t equal to negative 16 t square plus v naught 80 t plus s naught is the initial position. Find the velocity function, negative 32t plus 80. Set it 0, then 32t equal to 80, then t equal to 80 over 32 equal to 40 over 16, 20 over 8, 5 over 2, 2.5 seconds. Then find the position function at this time. S of 2.5 equal to negative 16, 2.5 square plus 80 times 2.5 plus 0 equal to 100. Choice C. Question number 39. A baseball is thrown upward from a height of 3 feet with the initial velocity equal to 128 feet per second. Determine its maximum height. First, this is the position function of the vertical motion when the velocity is in feet, and time in seconds. Find the velocity function, find the derivative of this function, plus v naught. V naught is 128. Set 0 to find when the time reaches the highest point. Plus 32t equal to 128, t equal 128 over 32 equal to 4. Then, in the position function, find s of 4, negative 16 4 square plus 128 times 4 plus the initial position is 3. 259. Choice B. See you next lesson.